Hello, everybody. Welcome to Distance Learning Week 2. This is Mr. Greco, and we are going to continue to work on graphing absolute value equations. I know we did a little bit of that last week, and as you're going to know, because I'm going to give you guys a video introduction on Google Classroom now, even though this is not due yet, it's due for your attendance, and I'll be grading on participation. So I want to make sure everyone does this and does it the best they can, because if you don't do it, you're not going to be here. So anyway, so the purpose is investigate absolute value functions by experimenting with graphs. We'll be able to write a V-shaped equation that has the shape and location we want. So this is a Desmos activity that I'm going to assign you guys. And the good news is you can watch this video and then do the Desmos activity and you can get most of it done. All right. So let's move on. So that's the first screen, and we're going to go to the next screen. Oh, here we go. Wow. We move one forward. All right. So it says make a table. So this is y equals the absolute value of x. Now, if you remember, the absolute value of an equation is basically the distance from zero of any number. So, and that distance is always positive, right? Because we're never to negative 5 feet away from people. We did talk about this before the groups broke up. So I'm just reminding you. So when it says here the absolute value of -3 is 3, right? The absolute value of -3, what distance is -3 away from 0? And it's 3. So we put 3 in. And then we put in the absolute value of -2 is 2. And the absolute value of -1 is 1. And then the absolute value of 0 is 0. And if you notice the green dots over here, right, are kind of showing you kind of those points on the plot. All right. So then the absolute value of 1 is still 1 away from 0. It's not negative. It's still 1. And the absolute value of 2 is 2. And then the absolute value of 3 is 3. So there we have how to do, and this is called the parent function. So, and if you notice, it looks like a V. And it starts right on the origin, right? That's called the vertex, where the graph turns. So we have where the vertex where the graph turns, and then it makes a V. So, and again, that's called the parent function. So that's how you graph. That's how you make the table, and that's how you graph the parent function of y equals the absolute value of x. All right, now we're going to go to the next one. So it says now y equals the absolute value of x, right? Plus k. So if you notice, the k is not inside but outside the absolute value, and we have k equals 0, and it's on the origin there. So let's see what happens when we move k, right? When we move, let's still, well, if we move k, right, to a positive 2.5. If you notice, that's positive 2.5 here. Let's do a whole number so that if it's a 3. Right, that's right 3. 2 and 4, and it's right in the middle, so it's 3. And if we go 4, it's going to be right at the 4. So that's what this means, right? That the k tells you, this number that we're adding or subtracting, tells you whether the graph goes up or down from the parent function. So I'm assuming, let's say if we go to negative, let's go to -4, and it goes down from the parent function 4. So if it's positive, outside the absolute value goes up, and if it's negative, it goes down. So that's one of the most important concepts to understand when graphing absolute value. Let's go next. All right. So what the value of k do to the absolute value function? So this is 0 and 10. So I think we're going by 2.5. I don't love that, but so this goes up, right? What does the value of k do? It moves the graph up.